Okay, so in this video, we are going to be talking not about what people can afford, which is what budget constraints describe. We're going to start talking about mathematically, how do we represent what people actually want? In economics, we're going to talk about that being people's preferences. So when we're looking at how people choose what goods to consume, it's a combination of what they can afford and what they want. So we've spent a couple videos looking at how to describe what they can afford using graphs and equations, and now we're going to look at mathematically how can we describe what people actually want or what they prefer between goods using graphs and equations. Okay, so we are going to start again in our world where we consume only Pop-Tarts and Diet Coke, which in some places might seem like a simplifying assumption, but in Mr. Heilman's summer world, this is pretty close to being realistic. Okay, so we are assuming we're starting here at this point, which represents a scenario where I am consuming 4 boxes of Pop-Tarts and 64 Diet Cokes. I'm going to assume this is per day. So the question is, the situation is when I'm consuming that bundle of goods, so 4 boxes of Pop-Tarts and 64 Diet Cokes, I get a certain amount of happiness or satisfaction from consuming that. So the question is, if I had to draw another point somewhere on this graph that would make me equally happy, so would give me the same level of satisfaction, but with a different combination of Pop-Tarts and Diet Cokes, where might that point be? So if I am going to be equally well off, if I move down here to a spot where I'm consuming less Diet Coke, so at star, I've moved down vertically, so I'm consuming less Diet Coke, but I am consuming the same amount of Pop-Tarts. Is it possible that I am going to be equally happy at that point? And the answer is no. If you're going to take away some of my Diet Coke, if you want me to be equally happy, you're going to have to give me some more Pop-Tarts. So if you're going to reduce my amount of Diet Coke, so if you're going to move me down vertically, you're going to have to move me over to the right, which symbolizes giving me more Pop-Tarts. So star could not possibly be equally happy as our initial point, but the red dot could be. Blowing up. So it is possible that at point A, hello, the pen's taking a vacation again. So if this is point A, 4,64, I could be equally happy at point B, the red dot, because there, even though I have less Diet Coke, I have more Pop-Tarts. Okay, so on the next slide, drew a graph of that. It actually has an official point on there. All right, so here I went from the blue dot was my initial consumption point to the green dot. So I could be potentially equally happy at these 2 points. And for the sake of this example, I'm going to say that we are equally happy at those 2 points. So then the question is, if we were to continue that experiment and were to draw dots on all of the points that make me equally happy as point A, what would that look like? So we know we started here, we got a point. Looks like I took away a lot of Diet Coke. Oh my God, with this pen. And got only a few more Pop-Tarts. What would it look like if I put a point on every single one of those? So in order to answer that question, we're going to need to think about a couple key assumptions that we use in economics about people's preferences. We try to make as few assumptions as we can, but we do need to make a couple in order to be able to do any work here. So in micro, we are always going to assume that all else equal, so holding everything equal, so prices and income and all that other stuff, if you get to consume more of a good, you're better off. So people always prefer to consume more. So more is better. So that's assumption number 1. For assumption number 2, While it is true that consuming more always makes you happier, each additional unit that you consume adds less and less happiness. So the first unit you consume increases your happiness a lot. The 20th unit that you consume, it does make you happier, but it does not increase your happiness by as much as that first unit did. Again, this is the idea of diminishing returns coming back. So first unit increases your happiness a lot, and then subsequent units increase your happiness, but by less amount. So this is the law of positive diminishing returns. For preferences, positive because each additional unit that you consume does increase your happiness, but diminishing because the amount of happiness it adds each time is less and less. Okay. So this is just back to the first graph we were looking at, 2 points where we're equally happy. So again, I had to give up some Diet Coke in order to gain some more Pop-Tarts. So when I go to think about where the third point on this graph might be, I might debate, is it the orange dot or is it the purple dot? So we started at the red dot, went to the blue dot. At both red and blue dots, we're equally happy. So which of the two next dots, the orange one or the purple one, makes more sense in light of the law of diminishing returns? Hang on, I'm going to try to get this pen to work. Okay, I think I conquered the pen. So far, so good. Okay, so the answer is that the orange dot is the one that's going to make me equally happy as the red and blue dots. What's wrong with the purple dot? Okay, so to think about it, when we went from the red dot to the blue dot, so at the red dot, I am consuming a massive amount of Diet Coke, and I have very few Pop-Tarts. So what that means is that 64th Diet Coke I'm drinking, that's adding to my happiness not very much at all. So I'm willing to give up a ton of Diet Coke in order to gain a small amount of Pop-Tarts, because I have so few Pop-Tarts. So because I only have 4 boxes of Pop-Tarts at point A, if you give me one more box of Pop-Tarts, because I'm at such a low level of Pop-Tart consumption, that 5th box of Pop-Tarts is going to increase my happiness by a lot relative to giving up so much Diet Coke. But now that I'm at point B, I'm now at a higher level of Pop-Tart consumption. If you look at the purple dot, it represents the same rate of trade-off as we had from point A to point B. If you draw a straight line in between those two, if you continue that straight line down, that gets you to the purple dot. So that would be suggesting that the rate of trade-off of happiness between Pop-Tarts and Diet Cokes is staying the same, even though the amount of Diet Coke and Pop-Tarts I'm consuming is changing. So when we go from point B to point C, let's call the orange dot point C, because I'm now consuming, when I'm starting at point B, I'm at a much lower level of Diet Coke consumption than I was earlier. This might be like 27 cases instead of 64 cases. So because I'm now at a lower level of Diet Coke consumption, my Diet Cokes are more precious to me. So if you're going to make me better off, or if you're going to make me equally happy, when you take away some of my Diet Cokes, right, you're going to have to give me more Pop-Tarts than you did before, because now the Diet Cokes I have are more precious to me. So if you want me to give up some of my 27 Diet Cokes, you're going to have to give me more Pop-Tarts than you did when we went from point A to point B. Oh, good. The pen stopped working again. And that pattern is going to continue if we were to be at point C and then try to find a point that made us equally happy as A, B, and C. Now I only have 20 Diet Cokes, so if I give some up, you're going to have to give me a lot more Pop-Tarts to make me better off, so I might get a point over here, point D. So we're going to look at what a whole curve that shows points that make you equally happy might look like. Assuming the pen keeps cooperating. Here we go. So if we were to draw a point on every single combination of Diet Cokes and Pop-Tarts that gave me the same level of happiness, it would look something like this. This is what the graph of equally preferred bundles looks like if it obeys the assumptions we had about consuming more is better, and that each additional unit that you consume increases your happiness by less and less. So one of the things that's going to be really important to understand is what the slope of an indifference curve means. So first of all, this graph that shows somebody's preferences where they're equally well off is called an indifference curve. Interesting. Okay. Indifference. Good. Great. Super. Just stop right in the middle of the word. So it's called an indifference curve because you are indifferent between any of the bundles along this curve. So here at the point 64 Diet Cokes and 4 Pop-Tarts, that makes me equally happy as this point over here, which I think is 64 Pop-Tarts and only 4 Diet Cokes. And any point along the curve, you are equally happy at any of these points. So at any point along the indifference curve, let's talk about what the slope means. So if, oh my God, this pen's going to kill me. The struggle is so real right now. Okay, so if we think about the slope of this indifference curve right here, what that is telling us is at that point, it is the rate at which you are willing to trade between the two goods to make you equally well off. So at this point where I tried to start drawing a red line, this indifference curve is pretty steep. So here, in order to make me equally well off, you're going to have to give me this amount of Pop-Tarts in order for me to give up this amount of Diet Coke. Oh my God, the pen. That's much different than at one of the two ends of the indifference curve. Like, let's say we are over at the point 64, 4. There, because I have so many Pop-Tarts, I'm willing to give up a lot of Pop-Tarts in order to get just a little bit more Diet Coke, because I have so few Diet Cokes at that bundle that the Diet Cokes are very precious, and so I'm willing to give up a lot of Pop-Tarts, which I have a ton of, in order to get just a little bit of Diet Coke left. So the slope of an indifference curve at any given point is called the marginal rate of substitution. So rate of substitution is pretty it's pretty straightforward because that's the rate at which we are equally happy to substitute one good for the other. Substitution. Marginal because it is the rate at which we are willing to substitute those goods at that specific point. So the rate at which I'm willing to trade between Pop-Tarts and Diet Coke at this point where I have a ton of Pop-Tarts and very few Diet Cokes is a lot different than the rate at which I'm willing to trade if I'm up at the other end where I only have 4 Pop-Tarts and 64 Diet Cokes. So the marginal rate of substitution only applies at a specific point along the indifference curve. But we are going to refer to it as the slope of the indifference curve at a given point because it reflects the trade-off. Okay. I'm coming up on the end of the amount of time for this video, so I'm going to go ahead and end this one and pick up in part 2. So let's stop here and then we'll pick up in part 2.